Today we're going to be graphing the tangent and the cofunctions, and remember that the tangent and the cofunctions all use sine, cosine, or both sine and cosine. And so we've got to consider what the tangent is before we can graph. Remember, the tangent is the sine over the cosine, and why this is important is because the denominator is going to pose a problem for us. When the denominator is 0, tangent is undefined. Well, all of the functions. Then the denominator, in this case, the cosine, is equal to 0, the cosine of theta, that's supposed to be, tangent is undefined, and that's going to leave or give us some asymptotes. So we're going to go through and graph the parent function, and I'm going to use the graph of the denominator as sort of a ghost function to help me do that. Okay, so I'm going to start like normal. We have our regular graph, and we're going to graph it out of 2 pi, because that's one lap around the unit circle. So I'm filling it in a very similar way that we've filled this in before. I think about 1 and I think about -1, although you're going to see that the amplitude doesn't really have any effect on, or it's not really applicable on these graphs. So I'm going to go ahead and graph that cosine, just do like my 5-point sketch of cosine. I'm just going to do it as like this little dotted function, because what I'm interested in is where it crosses the theta axis or the x-axis. This is where the cosine is 0. And again, when the cosine is 0, this graph is undefined and we have asymptotes. And so those asymptotes are going to happen at pi over 2 and 3 pi over 2 in the general unaffected tangent graph. Right. Then the rest of my tangent, you may remember what this looks like, but the rest of my tangent is 0 when the sine is 0, and it's going to approach the asymptote. It's 0 when the sine is 0 at pi, and it's going to be these little curves. So this is my parent function for tangent. The asymptotes will always be on the first tick mark and the third tick mark because they'll follow the graph of cosine. Even if I shift it and adjust the graph by changing the period of the graph or where it ends, the amplitude, the asymptotes will be on the first and on the third. Okay, so let's talk about period. I brought that up. The period of this graph is no longer 2 pi, because the definition of period is how long it takes the graph to repeat itself. And if you look, the tangent graph goes up and approaches the asymptote, and then at pi over 2 to the left it goes down. Well, then it goes up again and down. So if you look very closely at this graph, the repetition part starts after pi. And that's because it takes both sine and cosine to create this graph. So the period of the graph is going to be half of what we would expect for a sine and cosine. So the period ends up being pi. Again, this happens for tangent. Tangent and cotangent repeat themselves in half the time. So what do? We cut the period in half. Instead of it being 2 pi, it's pi. So tangent and cotangent, that's going to happen too. Other than that, the rest of the graph is kind of the same in terms of how you number it, etc. When we talk about amplitude on this graph, I brought that up too a little bit earlier. When I talk about amplitude of the graph, remember the amplitude is how far the graph is from the center. If you look at this graph rises infinitely and drops infinitely, and therefore the amplitude, I say, is not applicable. So I just do an NA on that one, not applicable. Let me fix my thing here. When the denominator, in this case cosine, is 0, the tangent is undefined. Okay, so let's go on with secant, graph our secant graph. Again, I've got to consider the sine and cosine when I'm doing that. In this case in particular, this is 1 over the cosine. So again, when the denominator is 0, the secant is undefined. Again, my denominator here is cosine. So when the cosine is 0, the secant is undefined, just like it was in the tangent. So when I sketch my graph, I'm going to use that as guidance, the cosine. Again, I have no adjustment on this graph, so I'm going to go out of 2 pi. These numbers should look familiar to you. I'll do 1 and I'll do -1. No, nothing in the front of the angle, nothing in front of the secant. But the cosine is going to cause problems, so I'm going to graph the cosine, sketch the little dotted graph. Just a little dotted graph, because what I'm interested in is these spots. Come on, just stay there. The spots where the cosine crosses the x-axis. So here's an asymptote, undefined. Here's another asymptote, undefined. Okay, when I think about secant, secant is the reciprocal of the cosine, which means that when the cosine curves down, the secant will actually curve up. Now they share this point right here because the reciprocal of 1 is 1. The reciprocal of -1 is -1. But notice when the cosine curves in one direction, the secant will curve in the opposite direction. They are reciprocals. Again, when the cosine is 1, and it's going to approach the asymptote. So it's these little sort of U-looking things. Well, the amplitude on this graph, again, if you look, it's how high it is from the center. This goes up infinitely. That's not applicable again. But the period of this graph, it's only made of one function, where tangent was a combination of sine and cosine. Secant is just 1 over the cosine, and so it's going to follow the true period just like cosine would. So this is going to be 2 pi. It's going to take that full time to repeat itself. It goes up on the right, then it flips upside down on the left and on the right, and then it flips up on the left. And so then it'll start all over again. If I were to continue this, then I would flip up on the right, flip down underneath, and these would continue forever and ever. Moving on to cosecant. Well, the difference between secant and cosecant is my graph here is 1 over sine. So cosecant will be undefined when the sine is 0. So when the denominator, in this case sine, is 0, the cosecant is undefined. And so when I sketch my original graph and make my regular old tick marks, this should look real familiar to you, 1 and -1. Then I'm going to sketch the sine in there as the problem, the troublemaker. That's where it's going to be undefined, when the sine is 0. So when the sine crosses the x-axis, that is when it is Am I good? I think so. Sometimes these things move. Okay, that's where my asymptotes are going to be. So these asymptotes happen at the 0 at the second tick mark at the fourth. So 0, 2, and 4, where you noticed the secant was like the tangent, those were both at the first and the third. So just like the secant, where the sine is curved down, the cosecant will be curved up. They'll share that point 1, they'll share that point -1. The reciprocal of 1 is 1, so they're going to share that point. The reciprocal of -1 is -1. Where the sine curves up, the cosecant will curve down. So the amplitude again is not applicable. The period on this graph, because it's only involving one trig function, will be our typical 2 pi. Again, nothing done with the angle. If I start messing with the angle, then that number's going to change. I just have to remember with tangent and cotangent, whatever I get, I cut it in half. So let's get to the cotangent. Cotangent is cosine over sine. Again, the denominator being sine is going to be the troublemaker. So I will sketch my regular graph, my 4 tick marks like always. 2 pi because there was no adjustment. I'll put my 1 and my -1 in there, even though my amplitude isn't really going to matter. I'll go ahead and I'll sketch the sine to find where my asymptotes are. It is at the 0, at the second tick mark, and at the fourth tick mark. Now, because it's a combination of both, it doesn't do the flip. It's not the reciprocal of cosine or the reciprocal of sine like the secant and the cosecant were, but instead this is going to be a little twist. It's going to be a combination of both. So my cotangent has the same sort of feel as the tangent did, but it's 0 is in a different spot. And it'll go up on the right and down on the left. 0 at 3 pi over 2. So it's these little twisty things. It almost looks like an x cubed, a negative x cubed function, where tangent has more of the feel of a positive x cubed function. So we'll have that look. The period again, because this is using both cosine and sine, you'll see that it repeats itself in half the time, so the period here is pi. The amplitude here again, because it goes up infinitely, is going to be not applicable in this case. Now, just like when we were graphing sine and cosine, when we start messing with the period of the graph and the number in front of the graph, some of the things on our numbering is going to change, but our final result, the cotangent will always look like the cotangent graph, the sine will always, or secant will always look like the secant graph, etc. So I just kind of have to remember a little bit what the parent functions look like. So we're going to move on to the next page, and we're going to do an adjustment. In fact, what I want you to do is see if you can sketch the tangent graph, the cosecant graph, pause the video, and then come back and take a look. I'm going to start with the tangent. I'm going to do that one, and you'll see the only thing that changes, the tangent graph is going to be the tangent graph, but you'll see the only thing that changes is the numbering that I put on it. So I numbered my graph. I just took the 2 pi over 2. I took the number in front here, this 2, and use that to get my last value. But I'm going to do this right away. The period of this graph is half of that end value. So the period of this graph is pi over 2. Well, now let's get the parent function for the tangent on there. Remember, when I sketch the denominator, cosine, that'll give me my asymptotes. That's where the tangent is undefined. So I get those. Here are my asymptotes. And then I can go ahead and sketch my tangent graph. Oops. These little kind of curves in here. What is the amplitude of this graph? It's not applicable because of the fact that that goes up infinitely and goes down infinitely on each side. I just have to remember to put in my asymptotes for tangent. Look at the original graph that we did. The tangent graph looks the same, and when we do our shifts, it's going to be the same too. It's just going to shift to a new start. I want you to go ahead and pause again and see if you can get the numbering for the next one down. Pause the video, see how you do, and then come back in a little bit. So I took the 2 pi, I broke that apart, that's 1/3 theta, 2 pi divided by 1/3, that gave me 6 pi. I used that to number. So I always start the same. This could be a cosine graph, a sine graph, any one of those graphs. At this point, I'm starting the same way. Now I'm going to get that cosecant in. Remember that the cosecant is 1 over the sine, so I need to graph the sine to get my asymptotes. So I'll sketch that sine where it crosses the x-axis, where it hits the x-axis or the theta axis, where it crosses that middle axis. That's where my asymptotes are. And then my cosecant is the reciprocal of the sine. They'll share that tippy top point and then flip, and they'll share the very low point, and then it flips in the opposite direction. The period of this graph is exactly what the period of sine would be, 6 pi, but the amplitude of this graph is not applicable. So again, I'm going to have you pause and see if you can finish the last two. We have a cotangent and a secant. So pause and see if you can finish that, and then restart it when you sketch the graph and check your work and see how you did. So I finished my cotangent and my secant graph. I just remembered that the cotangent is the sine, is the cosine over the sine. So I had to graph the sine to get my asymptotes. The sine crosses the x-axis at the 0, the second tick mark, the fourth tick mark. There are my asymptotes. And then the cotangent is the little swoop. So I graphed it in blue. Keep in mind the period is half that of a sine, a cosine, a secant, or a cosecant, because it involves both of the functions, so it's going to repeat itself in half the time. So my n number was 4 pi. That came from 2 pi divided by 1/2, and I cut that in half to find the period. Amplitude not applicable. Going through the same thing with my secant, 1 over cosine. I graphed this cosine first to find my asymptotes. The numbering, I took 2 pi over 2, that came from this number here, to get that end number. Because it's secant, the period is the same as it would be with the cosine and the sine, that's pi. The amplitude is not applicable. Notice that my flip happened here at 3, because that's where the cosine would top out, and -3 is where it would bottom out, and my flip from there. So they share that point, that one point that they share, and then it's the reciprocal of the rest of the graph.